stands at a pivotal moment where the convergence of human ingenuity and machine intelligence is unlocking possibilities we once thought belonged to science fiction. Good afternoon, dignitaries, esteemed faculty members, and my fellow colleagues. Today, I, Divyanshi Singh from the batch of MBBS 2023, would like to welcome you all on behalf of the Mediquist Society and the entire Student Council of Mahatma Gandhi Medical College. I extend a warm welcome to our chief guest, Dr. M.L. Swankasa, Emeritus Chairperson of Mahatma Gandhi University of Medical Sciences and Technology. We're truly honored to have you with us, sir. We also welcome Dr. V.K. Kapoor, sir, Pro Vice Chancellor, MGUMST, Dr. M.D. Soni, sir, Dean of Faculty of Medicine and Surgery, and Principal and Controller of Mahatma Gandhi Medical College and Hospital. We now welcome the speakers for today, Professor and Head of Department of Clinical Hematology, Mahatma Gandhi Medical College, Executive Director of the Indian Cooperative Oncology Network, Founder President of the Asian Cardio-Oncology Society and Integrated Academic Society of Clinical Oncology, and an infinite list of credentials, Dr. Purvis M, Parikh, sir. We're also honored to have Dr. Chetan Arora, sir, with us virtually. He's a professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Delhi. He has published more than 70 papers in top journals. He co-founded 3 startups, all working on computer vision products, and also committed to applications of computer vision for persons with disabilities. He's currently researching matters such as trustworthy AI, cancer detection, and problems with social impact, to name a few. I now invite Purvis, sir, for him to apprise us on AI and the future of medical education.
And though the topic talks about the future of medical education, I will only talk about the present. And I will only talk about tools that are useful to medical students as of today. Mic is not working.
It's working. Can you
Lift it up. Okay. Is this better? Okay. So my first question to you is, I'm going to ask you people to raise your hand. How many of you have brought your computer to this hall? Please raise your hand. Wow. So unfortunately, I have to wake you up, guys, because each and every one of you has a computer in your pocket that can also make a phone call. Okay, please understand, the power of your smartphone is that it is a computer. So while we are, having a life that is extremely busy, we have to focus on being smarter rather than working harder alone. So I was there at a workshop recently where I was talking about hematology, and I saw 3 people taking notes on their iPads. So during the coffee break, I took them aside and discussed with them how they are using the iPads. And my entire talk for you now, from now on, is about what tools you can use from artificial intelligence in your day-to-day studies. So first is Geeky Medics. All of you must have heard of flashcard. Yeah? When you want to revise, when you are giving an exam, you want to use flashcards. And this is a free medical flashcard program that is available to all of you. But there is one which is even better than this. And that is called Revisitly. And in this Revisitly, you have 3 parts of making flashcards. Okay, the first step is to upload the information that you want to make the flashcard of. Second is to practice. And the third is to take the exam. Okay, all these 3 are possible on this software. So what I have done, you can upload any, either text or a PDF or a JPG image. In this instance, I have taken the example of uploading a JPG image. So you can see that JPG image has 4 components, and it talks about polymerase chain reaction, which is a molecular test in the lab. So I upload that, and this is how it does. So flashcards are ready, and you can choose the font, and you can choose how many flashcards you want in one particular area. And then you can download them. So this is the downloaded flashcard. On the left side is the question, and on the right side is the answer that you are expected to give. And this is all done in a matter of few seconds based on a JPG image that you have uploaded. And then when you want to use this, it will ask you a question, and then you can see whether you want to practice or take the exam. So you can select what you need to do. So this is the question that is on top. I have typed the answer that I wanted to give it, and then it analyzes this answer. So in the green is what was right in my answer. In the red is what I missed out while giving the answer. And in the purple is what else I could have said in giving the answer. So I think this makes it extremely easy to do revision of whatever you intend to study. Now let's go look at another software, that is Heamatology. And this is to ask questions to a PDF. Okay? So this can be used on the smartphone or your laptop or your desktop. And when you have uploaded the PDF, it is shown on your right hand side. On the left hand side, you ask questions. And below your questions will be the answer. So in the first question, the answer is not there in the PDF, so it says, sorry, I cannot answer that. In the second question, the answer is there in the PDF, so it gives the answer, and it also highlights in yellow the text in the PDF that represents the answer. And then you can ask something smart. So I say, what was the deficiency or what was missing? And it is still able to give the answer of what is missing in the PDF. Now this is the power of artificial intelligence that you have today. Now let's look at consensus. Let us suppose that your teacher has asked you to do some research or to do a project. You want to know how valuable this project is going to be. Is the title okay or not? What else is there to be done? So then you go to consensus. In this, on the top, you type the topic of your subject. So here you can see I have typed the question. Is cure possible in childhood cancers? And then it searches the entire world of literature and gives the answer. Answer is yes, maybe or no. And in this instance, the answer is 100% yes. What this means is that sufficient studies have been done and there is evidence, so there is no need for doing any further investigation on this study or on this subject. The next subject is, can we reverse sarcopenia in frail elderly? And you can see that there is a small percentage of yes, but the maximum answer is maybe. What this means is that there is total uncertainty in this topic, and if you do this research, then you are likely to get the right answer in a short amount of time. So if I was doing a thesis where I have to complete the job in 1 year or 2 years, this is the topic that I would select. And then let's take one more example. Does cancer screening improve all-cause mortality? And the answer is 40% yes, 40% no. What this means is this is a very difficult topic. Lot of work has been done here, but nobody has found the right answer. So if I want to do study on this topic, I will have to plan for a 5 years or a 10-year project. So I would not recommend students to do this. So this consensus helps you in identifying a research topic that is possible to be done within a short frame of time. SciSpace is another one that is for research platform. And here I have asked the question, what is the difference between cancer specific versus all-cause mortality? And you can see that it is divided the answer into two subheadings are there. One is cancer specific, the other is all-cause mortality. And then on the left side in green you see the title of the manuscript or the reference. In the middle column you see the extracted information that supports or refutes the statement. And on the right hand side you see options for adding more columns. And any one of these columns can be added based on what is your requirement for doing the research activity. And this is colorectal screening recent advances. And again, instead of just focusing on colorectal screening, it talks about stool tests and it talks about blood tests. So this is really up to date. Whatever has been published till 8 AM in the morning, you will find that you can access and reference that. If you can't find the full text, this also allows you to directly send a message to the corresponding author, and hopefully that corresponding author will send you the full text article also. Now POP AI is very useful for two reasons. One is to make PowerPoint presentation, the other is to do medical writing. So let's start with PowerPoint presentation first. So I have used this topic, use of AI tools to improve patient understanding of cancer management. So this is less than 15 words, you put it in there and instantly there are 20 topics and 20 slides that are made. This takes less than 5 or 6 seconds. And this is the slides that have been created. You can clearly see wonderful, nice, attractive slides that are created. Instead of working hard for 3 or 4 hours, you can work smart for 3 or 4 seconds. And let us say that you have this slide and you don't like the image that is shown here. Okay, that the vanilla nails is not appropriate for what is the topic. So what do? You can ask AI to generate an image that you like. So I have shown the prompt at the bottom, and there are 3 different apps that can be used: Gemini, Meta AI and ChatGPT. And you can see how beautifully and vibrant the images that they have created. You can, give a very, very detailed prompt of what exactly you want, and that is what I have done here, because I wanted to show an image of a patient being counseled by the doctor. And when I do that, this is the image that was created on the top left hand side. That was a Caucasian person, so I said, no, I want an Indian person. So this is the Indian person. Then I said, no, I want an older Indian person. So this is the image that they created. Then I said, I want this in the background of a busy slide, busy OPD, where the patient and the nurses, the doctor and the nurses are explaining, and that was the image created. Then I had to give a lecture for Russia. So I said, let us do it in the Russian context, and this was the image. So in a matter of 15 seconds, you can get whatever image you want based on artificial intelligence. And then you can select those images and put it in the slide. So your slide is ready with the image that you want. Now let's go to POP AI for manuscript writing. So here I have taken the example of AI tools to facilitate studying for medical students, the topic for today. And you can clearly see that there are subheadings and 6.2 subheadings. The whole lecture is ready. What I should speak and what I should say is already available here. Now let's move on to another article writer, that is Picasso. And here, let me go backward. Here I said adjuvant breast cancer therapy. Now artificial intelligence is not human, right? So the word breast was alerted. Why I cannot use the word breast? That is supposed to be sensitive topic. So then I had to change the topic to adjuvant cancer treatment. And in the subtopic I wrote specifically compare 2 drugs that are used for breast cancer. And this is the sort of information that it put. Again, it takes a few seconds to get as much detail as you need. Another one is Deep AI, and you can specify what is the duration, what is the length, how many words you want for that, and then it will create whatever is necessary. And I just want you to focus on the first sentence, because I will show you an example of this, how I have used this text for something else. So just keep that in mind. Now when students are smart, teachers have to also be smart, right? So we have to make sure whether the students have used their own human brain or they have used artificial intelligence. So these are the 6 things that I use to make sure I understand what attention, how much attention the student has given, as opposed to using AI tools to give their homework. Now Zero GPT is one such example. So like ChatGPT, Zero GPT will tell me whether something was produced by artificial intelligence or not. So I have taken the text from the earlier example, put it here, and it shows that it is more than 90% generated by artificial intelligence. So it's very easy to find out when somebody has done something like this. So when how to be richer, smarter, better looking than your teachers is the situation today, because that teenager or youngster is teaching his grandfather how to use technology. This is what happens to us today. So there is a way to humanize text. Okay, so students say that I don't want my teacher to know what I've done. I will put the original text on the left hand side and the AI tool will humanize the text so that the teacher cannot find out what is it was generated by artificial intelligence. So I put the text here and in 11 seconds, it will give you the humanized text. And it also colors it differently so we know what was generated originally and what has been changed. And now if you put this humanized text back into ChatGPT, it will say that this is 0% AI generated. Okay, the students are always smarter than the teacher. They will find a way of ensuring that they are not caught. There is small SEC tools also that allow us to use many other things. And this is a plagiarism checker. So one is to check whether it was generated by artificial intelligence. The other is to check whether that is, cut and paste from other publication in public domain. So this is a plagiarism checker. And for this instance, I have used that same text that was generated earlier. And what does it say? You can say that it shows what is the amount of plagiarism that exists. Taking another example of that plagiarism checker, and this is an article that I had written myself. So it is there in public domain, it can be referenced. And it clearly shows how much is it that is plagiarism. Here again, you can use tools like article rewriter. So that you have copied, cut and paste from a published article, but now it will change the wording so that it will not be caught as plagiarism. And when you do that, you see this is 100% original that has come. So students, your job is much, much easier than it was when I was a student in your place. And Zero GPT has a bouquet of other artificial intelligence platforms which all of you can use to your benefit. It is also possible to summarize what you have done. So I am coming back to Zero GPT to summarize. And this can be either uploaded or you have typed the text in there. And you can see that the summary is come down. So on the right hand side is the article that Dr. Shyamagaral and I have written. And this is the summary on the left hand side. And you can see that it has clearly reduced the amount of words and the amount of characters in this summary. And on the right hand side, you will also see how good is the evaluation of the summary. It will tell what is the level for the person who is reading it. Is it for an undergraduate student? Is it for a school student? Or is it somebody who is technological savvy? And if I have to use this to give a lecture, it will also tell how much time it will take for me to read this or for me to use it to give a lecture. And therefore, supposing I have a slot for 15 minutes, then if I can put that text here, it will tell me exactly how much time it will take for me to complete my lecture. And then if you need to paraphrase, of course, paraphrasing is easy. And again, it will tell you exactly what has been changed and how much is the change in the number of words. In this instance, it increased from 219 words to 272 words. So paraphrasing tool has got several key features and I will not bore you with all the details here, but you can look at it. Now, how teachers can outsmart tech-savvy students by Indian jugaad. Okay, this is not artificial intelligence, this is human intelligence. This is what I can do. So I will give an assignment to the students and in the last slide you can say, in your reply, please include a sentence that this was generated by artificial intelligence tool. Now most students don't read, they will just cut and paste and put it there. And then when it is generated, that sentence will come that it was generated by artificial intelligence. But some students are smarter than teachers, right? So they will eliminate that. So how do I do something about that? First, I write that in the Word document. Then I highlight that particular sentence that talks about artificial intelligence and then I change the color to white. Okay, so white text on white background, nobody can read. No humans can read, right? And now when the student does cut and paste, that sentence is not read by the student, but it is read by the artificial intelligence tool. And therefore, when the answer comes, you can see what I have highlighted in red. There is a sentence that it was generated by artificial intelligence. So, ladies and gentlemen, there is an artificial intelligence for anything that you can think of. And this is the website that says there is an artificial intelligence for that. Anything that you want, it is available there. And if you are really interested, there is a global summit on artificial intelligence and health. That is on 14th and 15th. And you can send me a WhatsApp if you want to attend this online. But finally, humans can still outsmart artificial intelligence tools. And what got you here won't get you. With that, I will stop here. And thank you very much for a patient hearing. Are there any questions? Sir.
The images of people which all these tools use, suppose they use my image, can I question that?
So, the artificial intelligence tools have been trained on millions of images. And those millions of images were something that was generated by human being or a camera. So, the artists and the artists who were making artworks have actually sued OpenAI, saying that you are infringing on the copyright. So the case is ongoing. But the image that is generated, and you can see this is one photograph is real, one photograph is generated by artificial intelligence. It is slightly different, and so legally they will get away with it.
Even if it is slightly different, they are kind of impersonating me. Suppose they use my image to provide an answer. I can challenge them.
So they will never provide your image without change. The change is significant enough to say that it is not your image. Right, sir. Thank you very much.
Sorry, pull you back. Now, for the students' assignments, what is the official position today? May not be in our country, but abroad. How is it taken?
So when ChatGPT first was launched, Italy banned ChatGPT. They said we will not allow it to be used in our country per se. And then ultimately they have to reverse that decision. I feel that artificial intelligence tools are here to stay. They make a big advantage and make the job smarter. So we should not stop the students from using it. Only thing, we have to make sure that they use the human brain as well, and therefore give the assignment in such a way that they have to use artificial intelligence tools, but also interpret it and give their opinion on what it is.
And what about scientific publications? What is the policy of the journals for use of AI tools?
So there has been a lot of discussion on this. There are some journals who refuse to accept. But if you look at journals which have published articles which are 100% generated by artificial intelligence, you see that they number more than 70. So there are certain journals who officially accept manuscripts that are generated by artificial intelligence. So it's still an open debate.
I think there is an ongoing discussion amongst the top journals
Yes.
to how to deal with this problem. Similarly, discussion amongst top universities as to how to deal with assignments. Because if a student is answering a question or generating a report or writing a thesis, then you're not using your brain. You're just typing in the right search strings, and the computer is generating the input for you. So you don't know that text. That text is not yours. So
Very true. But the students and technology is smarter. They will paraphrase and they will humanize the text. So it is extremely difficult for us to identify whether it is they have generated this out of their own brain or that they have used the AI. So it is very critical.
So maybe you will have an AI tool to detect paraphrased text.
So I'm sure that somebody is working on it, but at present it is not available.
But looking at it from another point of view, suppose the purpose of writing, say, a review article is to provide the reader all the information on the subject. If I do it myself, obviously I cannot be 100% complete or correct. There will be deficiencies, there will be mistakes. Whereas the chances that AI will make those mistakes will be less and deficiencies will be less. So from that point of view, if it is only provision of knowledge to people, probably these tools are good.
Absolutely. I entirely agree that the tools are good. It generates an output. Then we have to use our brains to interpret the output and give insights based on the real world situation. So unless we do that, then it is not going to be as useful as it's just a computer generated output.
So, as a senior teacher, what would be your advice to these young boys and girls sitting in this hall? How best they should use AI tools for their studies and what they should not use, at least at this stage?
So anybody who is not familiar with or not using AI tools is not going to be successful. Okay? My 4-year-old grandson is able to use the smartphone and do lots of things which we are very surprised. So having the ability to use a tool is exceedingly important. We should definitely encourage it. The next question is how to use the output to make it more useful. And that is where the human logic or philosophy or contextual thinking comes into the picture. Let us say I am treating a patient of breast cancer who is triple negative and the standard of care is X, Y, and Z. But then I have to interpret that X, Y, and Z in the form of the person as a whole and not the patient with breast cancer alone. And therefore I have to look at liver functions, I have to look at agility, I have to look at the social support at home and so on and so forth. Putting all of that together, AI cannot do right now. And that is where our expertise comes in.
And I think we also should keep in mind the young people who are intending to use this or use this, कि the software or this technology ये खूब दापता है, मतलब खूब गप्पे मारता है, and lots of incorrect information is there. I was writing an article on CML, so I used this not to write the article. I just put a string that search for publications from Heamatology from 2000 to 2023. So it threw up 15 or 16 articles. I was very happy कि मैंने 16 articles लिखे. All of them were fake and fabricated. All of them. So please be very careful and look at the text very, very carefully and recheck and re-verify, because literature search, PubMed search, these engines are not very apt at doing. So if you're doing a scientific writing a paper, particularly the references, please make sure that you cross-check each reference.
Thank you.
I'm not an expert on AI, but whatever little I have heard and learned, mainly from Dr. Parikh and few others, my suggestion to students would be that, as Dr. Parikh said, that yes, you should be and you ought to be familiar with these tools. What are these tools, what they can do, how to use them. But don't completely rely on them, don't completely use them to do what you are told to do. So I'll give an example. Suppose you are asked by your teacher to write an essay on some topic. In medicine, we don't call it essay, we call it a review. In school, we used to call it essay. So yes, to gain knowledge, you can use the AI tools. That what is the information available on this topic, on this subject. But writing part, I would still say that although it is very tempting that it can do it for you in 10-15 seconds, please don't use it for writing what you are supposed to write yourself. So you should know what it is, how to use it, but at least as of today in the medical school, don't rely completely, because even for postgraduates, as Dr. Hemant said, that the information that it is giving may not be correct, may not be accurate, it may be fake. So you have to be very careful and very cautious. Yes, you should know what it is. Am I correct?
Absolutely right, sir.
So I'd like to add to what Dr. Kapoor has just said. When you are going for your exams, you will not have your cell phone with you, and there you will have to produce and vomit out knowledge which is there in your mind. And number two, when you're doing a viva for your exams, then again you will have to come up with answers from your natural intelligence and not artificial intelligence. So do keep that in mind. You might be able to do 2, 3, 5 assignments, but when you are face to face with your examiner or when you are sitting in the examination hall with the question paper in front of you, you will need your own genuine human intelligence and the knowledge which you have added on to that intelligence.
Thank you.
Maybe I will interrupt here to introduce the next speaker because I know him personally. Dr. Chetan Arora is a professor of computer science and engineering at IIT Delhi, and he is here because some of my colleagues in PGI Chandigarh, which as some of you may know is a very prestigious institution, have done some work with Dr. Chetan in interpretation of the ultrasound images. So all of you students, medical students would know what an ultrasound is, and it interested me because my interest is in gallbladder diseases. So together with him we are planning, we have already done some work and we are planning further work, that if an ultrasound is done on a patient, say by a young inexperienced radiologist, can the video image be subjected to a machine, to artificial intelligence, which can then tell us whether it is normal, abnormal, if it is abnormal, what is the abnormality? And the final answer that we are seeking is that even if it looks normal, is there a possibility that there could be a cancer inside the gallbladder, which cannot be detected on the routine ultrasound? So that is how I got in touch with Dr. Chetan. We are exploring possibilities of other collaborations, and I have requested Dr. Chetan to just apprise you how artificial intelligence and machine learning can be applied to medicine, especially to read images, and this applies very well to radiology and pathology. These are two disciplines which are basically image reading. So those are two specialties where AI is going to play a very, very major role. And that is why when Dr. Pratibha came to me and said that we want to do this, I said yes, because as Dr. Parikh also said, that every student today, especially in medicine, has to know what AI can do it for.
So, see, I was hearing the previous talk, and I think I felt that as a technologist, maybe I can put a little context into the background, because I mean, these days what I have felt is the AI, or the discussion of the AI, is also about managing the expectation. Somehow, with all the commercial interest and this chat GPT and etc. going around, there have been overselling of the AI also to some extent. So I'll just present a few slides in which I would like to really set up the context, what really AI is and why we are really seeing this as a strong way. And then once we have done that, it will be able to set up the context for me and how to really, I mean, what is really good, what is really it's capable of, and what it is not capable of also. So, I mean, before I could start, this is the broad diagram of what the AI umbrella is. I mean, we are using the umbrella term for many things actually. But from the technology point of view, it can be subdivided into many other things. So in general, when we talk about the AI, we say that we want to mimic the problem solving and decision making capability of a human. Now, this problem solving and decision making could happen in various sub-contexts. It can happen in the context of images, or I may call the visual data. So in this case, it will be called computer vision. I hope my cursor is also visible when I'm moving it. So when I talk about mimicking the human decision-making capability in the context of images, it will be called computer vision. So the example of it is what you saw in the earlier slide when we were generating the images. Another example which as a clinician you all should be able to relate is all radiology. I mean, so we are looking at ultrasound images and X-ray images and CT images. These are all visual data, and we are trying to interpret this decision through the AI. So this will all fall under computer vision. Something similar I could have done with the audio signal also when somebody is speaking and I would like to understand. A classical example of this is when you talk with the Google Assistant or when you talk about the Alexa. So there they are trying to understand the human voice and then taking a decision. Other example is another is natural language processing, when we are speaking in a specific language to a machine, and then the machine is interpreting my language and giving the answer. And the nice example for that is ChatGPT, where you have the chat capabilities. You speak not speak really, you write in the natural language, and then you get the answer in the natural language. So AI, although is a broader umbrella term, but there are many small topics within it where technically we divide it. So you can think of it like as an MBBS, but then when you do the MBBS, you have a surgery and medicine and many other subspecialties. So, but why we are here? So why is, let's say, AI is becoming so different than what we were doing earlier? I've used the word here deep learning because deep learning is, let's say, the technical term beyond what we see as an AI. Most of the AI that we are seeing this day is actually driven through deep learning. So this is how we used to do traditional programming. So let's say if I give you a list of numbers and I say, okay, please find minimum from this list. So some student, let's say from IIT, will be writing a program. So we will have the data where there is a list which is given to me. There will be a program which has to be written by a student. These two things will be given to a computer, and then this computer will give an output, what is the minimum number in it, what is the maximum number, whatever I wanted to find out. So this is how the traditional programming is done. How the AI or the deep learning is working is that I would say that I have this data, this is my list from which I want to find the minimum, and I say for this list, this is the minimum or this is the number that I'm seeking. Then the AI system or the computer will generate a program which is what I will call the AI model, which will then be used for the new data to generate this out. Okay, so what has changed in this process is that both the data, which is the input, and the output that I see goes into the machine, and an AI model comes out, which is actually a program. Why I'm calling this a program? Because AI model is nothing but a sequence of additions and multiplications. So is this program actually. So now whatever plus and minus I would like to seek from the AI is actually in this slide. What you can see here is that this program is written by a computer itself. No human has written this program. So the first implication of this program is that the expertise that was required into generating this program is gone now. It's not needed because computer is generating the program. So what you see is that, let's say 10 years before, if I were to write a program on doing a breast cancer detection, I have to really understand what the breast cancer image looks like, what are the features. I will be extracting those features and then doing some program on top of it to generate that output. So this program required a lot of interdisciplinary skill from the computer program as well as from the radiologist. Now the moment I say that the computer is generating program, both of this is not really needed. So you take some data, which is now the mammograms, you take the output that whether from the biopsy this is plus or minus, the malignant or benign, and then comes out a program which can generate this output from this data. But now the flip side also comes along with it. This program is written by a machine, so I do not really know whether it's correct or not. All I know is that on some data, some output that I wanted to generate has been generated. Whether this program really understands what this data is, no guarantees. Will it keep on working on any new data? No guarantees. Does it have any trapdoor hidden in it? No guarantees. Does it have any bias in it? No guarantees. Can I even understand this program? No. Because this program, see that, is a sequence of 130 billion multiplications and additions. How do I even know what is the logic which is being processed into these additions and multiplications? So even as a technologist, I have no understanding of this program, how this program is really being. So in some sense, now we are talking about this program now as an entity, just like we used to treat the human beings. So every human being has a brain of input. Can I really know that given this input, this human will react in this particular way? No, I may have some broad contours because there is a certain data that has been human being or the other human being will definitely react in this is the output of that human. So in the same manner, this program has become too complicated, just like the brain and neurons. This program has not been written by me, just like the biology sort of created this network connection. So this program has become uninterpretable for me. Or in other words, this is a big black box for me as a technologist and for you as a user also, both ways. Now let's understand how does it impact me. Okay, so that's what I say now. The AI is also about the managing the expectations. So you have seen in the previous lecture what are the all magical things that I can do with the AI. So I'll just show one example. So this is an assignment that I gave in one of my courses a few years back, which was on the pneumonia detection. So there was some certain data set, give a chest X-ray, detect a pneumonia. So some student came back and said my accuracy is 99% of this. So I was interviewed because it's a small data set, the student is doing first-hand program, and how can this be 99? And then we looked at closely, we have the radiologists also in our team, so we asked them to also look at that what really this model is doing. So what we saw is that this is the left image, which is classified as pneumonia. On the right image, this is classified negative for the pneumonia. Now we show this, and now the doctors are also interviewed because in the left image there is really no sign of the pneumonia. Okay, the lung patch, etc., not that visible. And then we came up with some other hypothesis. I think as a doctors, I mean you are also the clinician, so I don't have to tell you. So this the X-rays is taken two views, the AP view and the PA view. When the patient is lying on the bed, you will take an AP view because the patient is lying and the sensor will be below it. And in the PA view, the patient is standing, maybe healthy or otherwise. And because of the placement of the sensor with respect to the patient, the ribs will come in a certain angle. Okay, so that's what I have tried to highlight. So the AP view will have a certain ribs view and the PA view has a certain other view. Now I give this data to the model and the model learns pneumonia, not pneumonia. But it does not really have to really learn what is abnormal in the lung. It just has to learn if the patient is lying or not lying, or if the view is AP or PA, because if the patient is lying, most likely the patient has pneumonia. What else happened? If the patient is standing, most likely no pneumonia. So the data is correct. I mean, I have actually given you the right data. But the model that got generated, the program that got generated, did not really understand pneumonia, not pneumonia. It just overfitted on the AP and PA view. And because I have no direct way of really understanding the model, understanding this program, I have to be very careful now that I cannot trust just the outputs that the model is producing. So one is, I mean, increasing the statement that I use is that not only the program has to generate the right output, it has to generate the right output for the right reasons. So now the reasons are also as important as the output itself, because I know that there is a limitation on the data set. I can give 100 images, 150 images. Maybe these data sets are biased in a certain manner. For example, in this case, all the patients of the pneumonia that I will be getting will be in the diagnostic setting. The patient is already admitted to the hospital. So you will see all kinds of wire the patient may be lying down. Would we really have the pneumonia cases on the field when the patient is otherwise healthy and I can have PA view and pneumonia? Maybe I may not be able to match. In this case, I was able to decipher that. In other cases, I may not even have the wherewithal to really even do that kind of analysis. So it has become very important to really say that the right decisions has been made, but also for the right reasons. And if we do not understand, I mean, if we just use the AI, keep on using the AI as the black box, do some, give some data, get some output, the chances are that we may be introducing the bias in the system and it can hurt. Now, this is an image which I'm showing where the task is for the description. Now, I hope you are able to see the description. A man sitting at a desk with a laptop. So what's wrong with the description? There is no man in this picture, there is a woman who is sitting. Now, of course, as a technologist, I can argue that I have never claimed that the AI model accuracy will be 100%. It's 95%, so there is 5% error, and this image happens to be that 5% where I made an error from woman to man. But if I'm very careful on why this error has been made, then I will look deeper and say, what are the parts of the image which the model relied upon to really say man? And now what comes out is very strange because the model is not looking at the face here. So the red portion is where the model is looking at. So that this red portion is not at the woman's face. That I said that, okay, I looked at this particular face and maybe I made an error, this was not a woman, this was a man. But the model is really looking at the computer. So the decision that that a person sitting at the desk is a man is not decided by the face of the person, it's decided by the computer that is visible. So there's a lot of bias that we have in the data set. Maybe on the internet, all the image that I saw was computer and man, and that's why the model said whenever it's computer, just say a man, don't say woman. And understand that this program that I told is written by a computer, which is an optimizer. So if I give you a data which is 90% man and 10% woman, and I say please optimize, then the optimal answer is 100% man. So not only the biases will be retained, the biases will be exaggerated by the optimizer. We have to be very careful on that aspect, that the data is whatever the data is. I cannot say that my data is biased, I will not use it. The data will have biases. But what I should be, or what I need to control, is that the model does not have biases, which means that when as a clinician, you are given an AI model, just don't look at the output, look at how it has been done also. So this is another aspect. So now this is, a picture that I took from the internet. This is a similar problem which happens in the code writing also. So these days in the engineering schools, we say that there is a thing called Copilot, which can write the program for you. If I have to write a Python code, you ask the Copilot and it will write the program for you. Now, how do the experts use Copilot and how do the novice engineers use Copilot? And this is what we call the 70% paradox. The Copilot, which happens to be an AI model, will generate a very good code which is 70% correct. And that remaining 30% has to be done by somebody. If you insist that please correct this error in the 30%, it will generate new errors. So the code that is being generated is not directly usable. And now I will echo what was being said in the previous presentation. So there is definitely a role for the collaboration, where you use AI as a helping tool to improve your efficiency. But if you would like to use the AI tool as a standalone autonomous agent to really do certain things, there are many problems still that exist today. Will we be able to solve in the near future? We will see. But at this moment, let's not try to use the AI in the autonomous mode. Okay. Now let me just bring back to why I was being called here, which was our work on the GBC. So I have few slides for the GBC and few slides for the mammogram. We'll see what is the time and I will not go into the mammograms. So this is our work in the GBC net. So what we are showing here, so we've developed a particular model. So I think the audience here is not primarily technical, so I will not go into what exact model we made. We made certain model which could take ultrasound images and predict whether there is a gallbladder cancer in it or not. So the first two rows are what the radiologist accuracy was, radiologist performance was. The middle 6 rows are what are the other models which are available if I would have used them. And the last 2 rows are our model that we developed. So there were 2 variations of GBCNet and GBCNet plus V. So what you will see is that this accuracy, the first column is the 3-class accuracy when I say malignant, benign and normal. The accuracy 2 is when I say malignant and non-malignant. So both of them are useful depending on what context, so we report both here. And this specificity and sensitivity are the things. So what you will see is that in terms of the accuracy, whatever the radiologists are making, the accuracy is pretty low, and the GBCNet that we developed have a much higher accuracy. Now, we were very happy with this result, and then we actually saw, just like what I was saying, I made the right decision, but did I make the right decision because of the right reasons? So we checked that also. So these are the stuff where the model really relies upon when it says malignant versus benign. And the last column is ours, and then what you will see is that when it says malignant, it at least focuses on the gallbladder. Whereas when you look at the first 4 columns, not the first 4 columns, the 2, 3, 4 column, first is the top row. So column number 2, 3, 4, when you run the state-of-the-art model, the model is relying upon all irrelevant region, really even whatever accuracy that is. So one, the accuracy is bad, which is not surprising given that it's not even able to know where to focus upon. But even if I were to use that accuracy, I will be very hesitant because this is a classical case of overfitting. I am relying upon some unrelated features which are present in the image to really say whether this is malignant or benign. So even if it says benign, I will not be trusting that benign. Even if it says malignant, I may not be able to trust that benign. So this is what we have to really rely upon in this case. Now we were very happy with this, and then we started asking the doctor, why is the doctor accuracy so low? It cannot be too bad for the radiologist, plus 70% versus 90%. And the doctor came up with the reason that, that in this particular image, a radiologist is not able to really make out whether it's benign or malignant, but we typically see the whole video and then it's determined. And it was very surprising for us. I mean, it should have sort of known the day one when we started working the problem, but we somehow got it after 3 years of working the problem, that the image-based detection of the GB is perhaps not even the right way to formulate the problem. Because when I say that the patient is malignant, I say it for the whole patient. I say it for the whole capture, whole video that I have taken, and not on the single image. Whenever I say that the single image is malignant or benign, it's the radiologist's bias that I'm introducing into the system. So which means my specificity may be bad because of it. But this may also affect my sensitivity in the screening setting. So a patient comes to a doctor and I'm asking the doctor, please pick up some relevant images, some frames where you see some kind of abnormality, and then give it to the AI to really check whether it's malignant or benign. Now, if the radiologist is suspecting that the person has cancer, then the radiologist will find out some good frames to really for the AI model and give it. If the radiologist is not suspecting that it's a cancer, then the radiologist will pick up some random frames and give it to the AI model. There's no abnormality in that, the AI model will also say benign. Which means that if I actually pose the problem in the image-based detection, the AI model sensitivity gets restricted by the sensitivity of the radiologist itself. So we changed the problem statement. We said that, okay, this will not be the image-based stuff, this will be the video-based thing that we will do. So now the latest model that we developed actually took the whole video that the radiologist doesn't ask the radiologist to pick up the frames and then does the analysis on top of it. And then what we showed in this case is that actually the accuracy also improved and the sensitivity also reaches 1 in this case. I do not want to claim that it will be 1 always. But on that particular data set that we were testing upon, it actually managed to pick up every cancer that the patient had. So this is also now what I will say the interdisciplinary nature of the AI. So when we are working on a particular problem, we try to understand what are the nuances of that particular problem, and then we ensure that the model that gets developed actually gets developed specific for that problem, generates the right decision for the right results. And some of these things we deployed on the IIT servers also. So now this thing is something that you can use from outside. You can upload your image. We try to say your prediction because again we do not want to become the autonomous agent. We want to collaborate. So we ask the radiologist first, what is your prediction? Although we do not use that in the prediction. We also ask if the ground truth is available. If the ground truth is available, can you really tell us? And then we have several models, so you can choose which model you want to run. And then it will give you an output. It will also tell you what regions or what are the frames which the model relied upon to make that decision. And it can give you the 3 class, what is the normal confidence, what is the benign confidence, what is the malignant confidence, and it can also give you the overall prediction. And this thing, because in many contexts the data cannot go outside the hospital premises because of the DPDP Act and various other privacy constraints. So we have made this, put this on a small device. So this is the device, the picture that you see. It's a 50,000 rupees device which a hospital can take. It's air gapped, so it does not require internet to do anything. You give it an image and it generates this output. And the image can, it's not that you have to put a pen drive to give it an image. So it can run on its own PAC server inside this machine. So all you have to do is put your ultrasound machine on the local LAN, put this machine also on the local LAN. You push it into your PAC server, which comes into this machine, and it gives you the output. So it's practically the 2 monitors that you are seeing side by side. You press one button from your ultrasound machine, the image goes to the Jetson, this device, and then it gives the output. So these are some of the videos. So in this case, I have just opened it so that you can see what is actually inside. In the previous case, you were seeing it in a box, but this is the real thing which runs it. So do I have some time, or I mean, I can go or I can stop here also.
Maybe a couple of minutes.
Okay, so I can quickly show some couple of things in the breast cancer also in the same vein. So this is the breast cancer detection work that we did. So I think I don't have to explain to all of you, but typically when we talk about the breast cancer detection, the radiologist will look at the 2 views of the breast to really ascertain whether there's a cancer or not. And it was very surprising for us that this is not true for the AI models. So the AI models typically will take one image, CC or MLO, and then say cancer, not cancer. Whereas whenever I show to the radiologist, they say, oh, cannot be done. And then, so we find only one work, which was, before our work, of course. So we found only one work which was talking about that this breast cancer detection actually should be done by the two views, both CC and amyloid together, and then it should detect it, not only on the basis of a single view. But so there was also technical flaws in that paper from the geometry perspective, from the computer science perspective. So we fixed that paper, and then we are, let's say, some sense the first method which says that the breast cancer detection should actually be done by the two views. Again, of course, there's a model that we have designed which is shown on the picture. But the important thing is not this particular design as a clinician. So what we should understand is even this basic concept that this breast cancer detection, what is the right problem formulation? Single image, two image, what is the right problem? It may not be too obvious to the engineers. So again, some interdisciplinary things come in, we understand how the image is being captured, what exactly the results is looking at, and then we try to mimic that into the AI models. So this is something that we did for the two views, multi-view that we call it. And then the similar stuff. So in the Western countries, most of the breast cancer detection work will be done in the screening setting. So patient will go through the annual checkup, which means that when a mammogram is being taken, there is no other data information which is available to you. I mean, there could be some other demographic data, but typically that's not fed into this. So the models will take single image and then generate an output. That's not the case in the Indian setting. So a woman is coming to an hospital. So this is a diagnostic setting now that we're talking about. Woman is coming to an hospital with some complaints, and then a mammogram is done. Now, in this case, it becomes really incomprehensible. Why would I not insert the complaints of a woman also into that model? So I have to say that, okay, these are the women complaints. This is the mammogram. Now, can you tell whether there is a cancer or not? Now, again, from the clinician to you say, oh, this looks obvious, but not so obvious from the engineering perspective. So we work with the radiologist. We say, okay, this is my setting. I mean, let's say 1 year before or 2 years before, I would not have been even able to tell what is screening setting and what is the diagnostic setting. Okay, so for us, it's just an image and an output. But now I understand the nuances between what is the screening and the diagnostic setting. So in the Indian context, when I'm talking about the model, most of the time I'm looking for a model which is to be applied to the diagnostic settings. Now in the diagnostic setting, I need to insert this so the patient complaint from the patient history, as we call it, and then we can generate a model which is much better. So this is what we done, and then we did some our own comparison with the commercial models also, and in most of the cases we work better than the commercial models. So we have done some deployments also. So we collaborate regularly with AIMS Delhi, but as part of the mammograms work, we also deployed in NCI Jhajjar. We collaborate with PGI, so we could deploy it in the PGI Chandigarh also. So the breast cancer work that you are seeing is already deployed in these 3 hospitals. Yeah, so that's all from my side. If there are any questions.
As I discussed with you, I am already talking to my radiology colleagues here whether we can share our ultrasound videos with you.
Yeah, sure. Thanks.
Also, mammogram, I haven't spoken to the mammography team, but I have spoken to the ultrasound team. And I think the next step would be pathology images, because they are also static images, and that is something on which maybe we can have a discussion. In the audience, I have a lot of colleagues from pathology. There are mainly students, but there are some faculty colleagues also. And maybe we will have a small video call session with you and with my radiology and pathology colleagues to discuss as to how we can proceed. As far as the ultrasound for gallbladder and mammogram are concerned, that since your model is quite well established and being used by other hospitals, that is something on which we can embark upon very quickly. Thank you for joining and informing us about the work which is being done by you. Thank you very much.